when you're not given the angle, like is here, we have to know how to figure it out. So if we do it as this one, cotangent 2 theta is equal to A minus C over B. That's how you figure out the angle, to get the angle of rotation. This is a bit of pain too. I have to make you do it, but I won't make you do it a million times, don't worry. So let's go through one of them. There are a number of ways to do it, but only 2 of them are what you could say are foolproof, I guess. I guess that's the best way to put it. And I want to find, and that's, that comes out to the, I've got my notes on here, and I need to find, basically, if you get it where it comes out to a 60-degree angle, or it comes out to one of the basic angles on the unit circle, that's what you want. So I need to find one of the problems that has that, and I can give you that first. And then there are times it doesn't come out to a unit circle angle, and you have to be able to know how to do that too. But I'm going to focus on the 2 examples that they give for that one. Okay. So is that from the problem that I first gave? Let me check my angle on this one. 1, 2, 3. Yep, this one was a little different. Okay, I'm going to use this. 7, I'm going to switch a couple of the numbers around from the one that we were just doing. From 7x squared minus 6 root 3 xy plus 13x squared minus 16 is equal to 0. So A, C, and B all come from here, where that's A, the coefficient of the x squared. The coefficient of the xy is B. The coefficient of the y squared is C. And then there's D and E for x's and y's, and F for the constant. But we're not going to need those because we only need these 3. Cotangent of 2 theta is equal to 7 minus 13 over negative 6 root 3. So you get a negative 6 over negative 6 root 3. Cancels out the negatives, the 6's become 1's, and you end up with 1 over root 3, or root 3 over 3. You like it when it's one of the ones on the unit circle. So you have to recognize that it's on the unit circle. So I'll make sure everyone gets that. All I did was I just took the A, B, and C and plugged them in. And when you look at this, it's like, okay, which ones are on the unit circle? And, or, really, first thing, you only focus on the first quadrant. Because notice what we did with the angle of rotation before is we rotated this way. You're always and only rotating that way, and you're only rotating less than 90 degrees. So you don't have to worry about going farther beyond that. That means that these particular ones are the ones that you'll want to watch for, and you want to recognize the cotangents of those, in case in case you have one of those, or be able to recognize them. So let's take for this one the cotangent of an angle is going to be not, let's see, for tangent it's y over x. For cotangent it's x over y. So that means it's square root of 3 over 2 divided by 1/2. The 2's will cancel, this one's square root of 3. So for 30 degrees, that's the cotangent, but that's not what we want. The cotangent we just came up with is square root of 3 over 3. And that means that that one you may be looking at, let's see, let's come up to this one, because for 60 degrees, there's no square root of 3's in here, so I wouldn't even bother with those. So here we have 1/2 over the square root of 3 over 2, which is 1 over the square root of 3. Rationalize it, and square root of 3 over 3. So the cotangent of theta is square root of 3 over 3. That's 60 degrees. So the cotangent of 2 theta is square root of 3 over 3. Well, I can call this anything I want, but the cotangent of an angle that's square root of 3 over 3, cotangent minus 1 square root of 3 over 3 is 60 degrees. So that means that 2 theta is 60 degrees. Whatever angle I want to call that, negative 1 of that is going to give me a 60 degrees. But then I divide by 2. So the actual angle for this problem is a 30-degree rotation. So before I do the next type of thing when it's not on the unit circle, let's just review that. For this part, you use that little formula. You get the A, B, and C from the equation. You plug it into that, and then you get the 60 degrees from the unit circle, and then you divide by 2. And so that's our angle of rotation. You could now use that to put into those two xy, to the xy formulas. You would put 30 degrees in here, and you would take those results and you would put those back into this equation and do out all those calculations. So think about those steps here. One is finding the angle of rotation, which itself has a bunch of steps to it. 2, getting x and y from it. 3, plugging x and y into the equation, working out the equation, and then graphing it based upon that angle of rotation. So these are pretty big problems. Thankfully for you, I will split it into like 5 parts on the test. So you'll do that, but each one of them then will count for you, so you don't have to do it like 7 times or 5 times for it. Because if you can do it once, this is enough to prove to me that you understand what's going on with it. And you aren't going to have to do it every day for the rest of your life, so I won't make you do it 50 times. All right, now, but I gave you, not quite a cupcake one, but I gave you one that you can find with just looking on the unit circle. Now let's make it that little bit a harder one. And that's going to be, let's take, okay. 32x squared minus 48xy plus 18y squared minus 15x minus 20y is equal to 0. This one's in the textbook, number 22, and a follow-on number 34. I'm going to go through all the steps of it. Not all of them. I'm not going to do all those calculations out here. But I will also give you the whole step-by-step results for it in a few moments so you'll see it. So you can write down notes as I'm going through this to think about what to do. Okay? So the first thing is to find the angle of rotation. So actually, not necessarily the angle of rotation. Think about something for a moment. We'll need the angle of rotation, but when I came back up to here, I got the angle of rotation for the purpose of putting that in here to get the cosine of theta and the sine of theta, and both of these. If I know what the cosine is, I don't really need to know the angle. So if I come up with the cosine of theta is 7 over 84, okay, great. I just put 7 over 84 in place of here, and I don't actually need to know that it's 12.43 degrees or something like that. I'm making up the numbers, but that's the idea. However, I will need to use the cotangent of 2 theta to get the cosine and the sine. So no matter what, I still have to do this as the first step here. So that means I will do A minus C over B. The A is 32, and I'm going to subtract, let's see, one thing is that that's supposed to be an 18 here. So for the y squared, please put in 18. And the B is a negative 48. So that one, 32 minus 18 is 14, and here we get negative 48. So we get is negative 7 over 24. That one's not one of the 4 main points on the unit circle. So there are things I have tried with making it tangent and flipping it. and a couple of other things which sometimes work, but sometimes because of the negatives you get something where you have to then rotate it 90 and you're not always sure. So although that's something you can try too, I'm going to focus on the steps that they show in the book for using the double angle formula, because this is a double angle. So what we have right now is that the cotangent of 2 theta is negative 7 over 24. So what I'll do with that, I'm going to use the fact first that for this as an angle, cotangent of whatever angle, cotangent, I'll say alpha, is equal to x over y. So we know that much that, because tangent is y over x. So we'll say x over y, which tells me that that is an x value for a certain triangle, and that's a y value. So let's do a little thing here. And if the x is negative, because you're doubling the angle, we're instead of the first quadrant, we're over here in the second. Because every angle that we have, remember, is in the first quadrant. So if we have a negative, that means that it's big enough that the doubling of it puts it into the second quadrant. So we're over here. So I'm going to go out 7, and I'm going to go up 24, negative 7 to this point, but it's 7 distance. I have a right triangle. Oh, well, I guess I shouldn't, okay, we did it the wrong way, because I need to meet here, because it's the radius I'm trying to find. Sorry about that. 24, so it's negative 7, 24 for that point, and I need to know this radius. Here's a distance of 24, and here's a distance of 7. Okay, so for this angle, the cotangent was 24 over, oh no, it's adjacent. It's negative 7 over 24. So the cotangent's this one over that one. But I want to know the cosine and the sine. And so what I need is I need to go here to here and here to here for the sine and the cosine. Okay? So that means I need to know what r is. So actually it's x squared plus y squared is equal to r squared. So you can do 7 and 24, negative 7 squared plus 24 squared is r squared. So I'll just tell you right now, all that comes to 625 equals r squared. So r is 25. Knowing that r is 25, I can come and do cosine, well actually I guess they do sine and cosine. So sine of, no, they do cosine, and I'll show you why. Write out cosine of 2 theta, because I did this as if it was alpha, but really, in reality, the angle is 2 times theta. Cosine of 2 theta is the x value of negative 7 divided by the radius of 25. So negative 7 over 25. Okay, with me so far? Okay. I use this really. You don't even really need this to just do x squared plus y squared equals r squared. So negative 7 squared plus 24 squared. That mainly focuses on why the 7 has to be the negative and not the 24. That means here it's negative 7 over 25. The reason why we only need the cosine is because the formula for sine theta for the double angles is 1 minus cosine 2 theta divided by 2, and cosine of theta is 1 plus cosine 2 theta over 2. So that means we would put negative 7 over 25 in there and negative 7 over 25 in there. Okay. At that point, you need to see and know that that's the step and method. Okay. I'm going to give you a bit of a break on the test because I will have you go at some point. I'm trying to think of whether or not I'll either give you this or have you stop before this or something like that. But on the ones where I have you go further and actually get the x and y, I will give you one of the ones that are on the unit circle so you can take that and plug that in. Okay? So I want you to see this, but I'm not going to make you do all these exact steps. I'm thinking about turning something like this into a multiple choice question or not. I'll have to see how much room we have on it. So this right now I want you to see for the understanding of it. Now, having said that, I want you to take this problem, this example, and take a look at. Please pass those. Please pass those on around, and I'll bring them over to you guys. And for you guys, I can't leave an extra. I can't get my fingers to take one away from there. So you got an extra? All right. So I cut and paste this, and take this first part, draw a line there where you can tell it's sort of twisted a little bit because I couldn't get the page copied just quite right. And notice that what up to here, this is where I just stopped. I got to here, and put in, and actually you could put in the -7/25, and focus on the fact that you get this. So now that you get that, you get 4/5, 4/5 for the sine, and you get 3/5 for the cosine. And notice then, that allows you to use this formula. The x's and the y's, and put in, instead of putting the angle, because we don't have the angle here, we didn't actually get what theta is. We do that at the end. Preview, take a look down the bottom. Since we know that sine is 4/5, you can do sine minus 1/4/5 and get 53 degrees. So now you get the angle of rotation by doing that. So it becomes useful for that. Now let's come back up here. You don't need the angle in order just to put in sine and cosine and give yourself that much. And now you have this one and this one. So you can think of it that way, or notice that instead of this, let's take this part and over here think of it as 0.6 x prime minus 0.8 y prime. And then this one, the same idea. This one would be 0.8 x prime plus 0.6 y prime. So that's what x is equal to, and that's what y is equal to. The steps on here now, keep it as the fraction. And let's follow along here. You won't have to write these out right now. What I'm going to be doing on the test is saying you can do it either way. You can do it with the fractions like this, or you can turn it into decimals. So, looking at this one, that was squared, and then here it is squared out. All multiplied it out. And then same thing with this one. This one's multiplied out to there. This one's squared and it's multiplied out to there. All of these are multiplied out, but then a bunch of things cancel out. So if I did it step by step, you'd see it, and you'll see it in a moment there. Multiplied by the same denominator, like we did with the 4 in the other problem, and lots of denominators go away. And then lots of other things cancel out, including all these xy terms. So those 3 xy terms are gone, and all the others combined. So because you end up with the x terms canceling out, x squared terms canceling out, where's the other one? Here it is. 2 288s add up to 576, so it cancels that one out. You don't have an x squared anymore. So you end up, because there's no x squared, you end up with a parabola, and you end up with that. So if you saw y equals 1/2, y squared equals 1/2, you'd know that 1/2 equals 4p, divide by 4, p is 1/8. So it's a very small little graph here. Let's see, it's y squared. So we are focused here in a very small directrix and a very small focus point here, 1/8 away. And your parabola is going like this. So you did that last month where you were graphing these, and actually of the ones I graded so far, you guys were doing very well with the graphing of the parabola, so you'll just do it again a couple of times like this. And then we rotate it. That's where now you get down to figuring out what the rotation angle is. 45 is about here, so 53 is maybe about here. And that means I'll come the same distance and I'll do my, I should have done this one as a dash point. And that's been rotated, if that's 53 degrees, now that's a rotated conic. Okay, so I said that you could do this in decimal form. So you could work this out, like you now see on that paper, and I started to do out with the other one. In a way, I enjoy working these out. I like to work them out and see everything cancel away, but it does take a lot of time and a lot of trouble. So take a look at this paper, and I want us all to look at it and analyze what's happening on this one. This is the same exact problem after figuring out that it was 3/5 and 4/5. So up at the top of it, it said here's the x and y, and remember, let's see, where am I? On this paper, I showed you that here we could, instead of writing it 3/5 and 4/5, 0.6 and 0.8. Well, that's what I have here. So 0.6 and 0.8, 0.8 and 0.6. And then, now, I reduced them in size, but all of this is the squared term. This is 32x squared here, all being multiplied out. Here is negative 48, actually down to, at this point, line 5. At this point, I put all the x squareds together, all the xy's together, all the y squareds together. So this one is the negative 48xy, and this one is the 18y squared. And then the negative 15x and negative 20y. But what's really nice now, you notice that things start canceling. So if you prefer doing it in decimals, you can do it in decimals, and they all cancel out. When you get down here to the bottom, you saw that the 32x squared basically all cancels out, and the negative 48xy all cancels out, along with some of the x's stay, but all those y's go, so that you're only left with a y squared and an x term. And you see how that cancels out. This is the best format because that allows us, or puts it into what we're used to now with graphing parabolas, because that allows you to do this graph. Okay? You can figure out what the P is and see that the focus point's really close and the directrix is really close for it, and that it rotates 53. This one I'd either have to give you or you'd have to go back to the beginning. Actually, you could use this, the cosine, let's see, yeah, cosine of 0.6, cosine negative 1 of 0.6 will give you the 53 degrees too. All right, so you'll have to do one for me where you can choose to either do it as fractions or you can choose to do it as decimals. Your choice. I will tell you that if you do one and you get like a square root of 3 over 7 and you end up having to make that, and you want to do it by decimals, go ahead and do it by decimals, but go 2 or 3 decimal places, at least 2 decimal places, and then recognize that if you're rounding, you might get to the end, and it doesn't cancel out, but it should, because if you look, you might get something like 7.003 and 7.004, minus 7.004. That should be pretty clear to you that those are probably supposed to cancel. So take the numbers with a slight grain of salt because of rounding, which means that you can be pretty confident that those are probably canceling if they're that close. Okay? So that's the only danger of decimals, is that you might have to round if it's not a 0.5 or like the 3/5 and 4/5 one. And I can't promise because I don't remember which problem I'm using for that part, so I can't promise what that one's going to do. But think of it again as what's reasonable, and that means you should, if you think something should cancel, it probably should. Okay. So, what we should have in mind is these steps And I think I wrote out a review of what they were from. Okay. So 5 steps to rotating a conic. Rotate a conic. Steps. 1 is to determine angle of rotation, or at least cosine theta and sine theta. That's because for the second thing, you need to do x equals and y equals for the x prime, cosine, etc. So I won't write it all out, just remind you that you're finding x and y. And then 3 is substitute x prime, y prime for those expressions. Substitute the expressions into the main equation. Let me increase that there, so. And you do all that in order to, and actually, all the work to get the rotated equation. So that's all of those steps to do to get down to that. Once you get that equation, then graph it as normal, then rotate it. Okay, sorry that's a little messy, but I'm trying to make sure I get this all in time. So you need to get that angle of rotation, or you get it in order to do sine and cosine. You get the x's and y's, substitute it into the main equation, do all those steps, and then graph it as normal. Okay, and like I say, you will have to do this for me, so make sure you get comfortable with how to do it enough, either by fractions or by decimals. I don't care which way you do it, just make sure you're able to get down to the equation that you can use so you can use the graph for it. What I will do is I will split this up so it's not one whole big long one. Like I said, I'll make sure that you have a cotangent one where you can do it, but I'll split it up too and probably have you do them different ones. So if you by chance you make a mistake on one part of one, it wouldn't affect you to everything else.